Core Vehicle Maintenance Principles. Introduction to the module. Understanding core vehicle maintenance principles is essential for ensuring the safety, reliability, and longevity of vehicles. Regular maintenance not only enhances performance, but also minimizes the risk of accidents and costly repairs. By mastering these principles, individuals can contribute to a safer driving experience and promote sustainability within the automotive industry. This module will equip you with essential skills, covering safe practices in workshops, efficient tool usage, an overview of vehicle systems, and key environmental and legal factors impacting vehicle maintenance. Learning outcomes. After completing this module, you should be able to understand workshop health and safety practices to reduce accidents and ensure compliance, learn proper tool handling techniques to improve safety, efficiency, and equipment longevity, gain knowledge of vehicle systems and their components for effective maintenance and repair, develop an understanding of environmental considerations and eco-friendly practices in vehicle workshops, understand legal requirements in workshops, ensuring safety, consumer protection, and environmental responsibility. Health and safety in the workshop. Maintaining a safe and healthy environment in the workshop is essential for preventing accidents and ensuring the well-being of all workers. Workshops often involve hazardous equipment, materials, and tasks, making health and safety protocols crucial to minimize risks. The importance of health and safety in the workshop are as follows. Preventing accidents. A well-implemented safety program reduces the likelihood of injuries and accidents. Ensuring compliance. Following health and safety guidelines ensures compliance with legal standards. Boosting productivity. A safe environment increases worker morale and productivity. Protecting equipment. Proper safety practices also help in maintaining and preserving workshop tools and machinery. Effective use of tools and equipment in a vehicle workshop. The effective use of tools and equipment in a vehicle workshop is vital for ensuring safety, precision, and efficiency. Proper handling and maintenance of workshop tools not only help in delivering quality services, but also extend the life of equipment and prevent accidents. Importance of proper tool usage. Ensuring safety. Proper handling of tools reduces the risk of injury to workers. Improving efficiency. Efficient use of tools speeds up repair and maintenance processes, minimizing downtime, reducing equipment damage. Misuse of tools can lead to equipment failure, costly repairs, or even hazardous situations. Ensuring high-quality work. Using the right tools correctly results in better workmanship and higher customer satisfaction. Key principles for effective use of tools and equipment. Selecting the right tools for the job. Selecting the right tools for a job requires matching the tool to the specific task, such as lifting, cutting, or diagnosing. Specialized tools, like scanners for engine diagnostics, are often necessary. Improvisation with incorrect tools can lead to damage to both the tool and the vehicle, emphasizing proper tool use. Proper handling and operation. Ensure proper handling through training and certification, especially for power tools. Follow manufacturer guidelines for safety. Use both hands when operating heavy or vibrating tools like grinders to maintain control and avoid accidents. Regular maintenance of tools. Regular maintenance includes inspecting for wear, such as frayed wires, and cleaning after use. Store tools properly to maintain functionality. For advanced tools like hydraulic lifts, scheduled servicing is critical for optimal performance. Types of tools and equipment in a vehicle workshop. Here is a list of common types of tools and equipment usually used in a vehicle workshop. Hand tools. Wrenches. Tighten or loosen nuts and bolts. Use the correct size to prevent damage. Screwdrivers. Essential for screws. Match the tip type. Flathead Phillips with the task. Pliers. Grip, cut, or bend wires. Insulated pliers are crucial for electrical work. Power tools. Impact wrenches. Speed up bolt adjustments. Adjust torque settings to avoid over-tightening. Air compressors. Inflate tires or power pneumatic tools. Regularly inspect pressure levels and hoses for leaks. Drills and grinders. Drill holes or smooth surfaces. Wear safety goggles and secure materials before use. Diagnostic equipment. OBD2 scanners diagnose vehicle issues by reading error codes from the engine control unit. Multimeters test electrical circuits, ensure proper calibration for accuracy. Engine analyzers advanced diagnostics of engine performance, require specialized training. Lifting equipment. Hydraulic jacks lift vehicles for underbody repairs, use jack stands for added safety. 2-post or 4-post lifts. For full vehicle lifts, ensure regular servicing and proper vehicle positioning. Creepers slide under vehicles for inspection or repair, check condition to avoid accidents. Welding and cutting equipment. Arc welders used for vehicle bodywork or exhaust repairs. Only trained personnel should operate welding equipment to avoid burns or accidents. Plasma cutters for precision cutting of metals. Ensure proper grounding and ventilation when using cutting tools. Introduction to vehicle systems. Vehicles are complex machines made up of various systems that work together to ensure smooth operation, safety, and performance. Understanding the basic systems in a vehicle is essential for maintenance, troubleshooting, and repair. Let's take a closer look at the different systems of a vehicle. Engine system. The engine is the heart of the vehicle, responsible for converting fuel into mechanical energy to power the car. It consists of several components, including cylinders, pistons, crankshaft, camshaft, and valves, working together to perform the combustion process. Types of engines. Internal combustion engines. ICE. These use fuel combustion within the engine to generate power. Electric engines. Electric vehicles, EVs, are powered by electric motors, using battery-stored energy instead of fuel combustion. Key components of the engine. Pistons move up and down inside the cylinders, converting fuel into motion. Crankshaft converts the linear motion of the pistons into rotational motion to drive the vehicle. Valves control the intake of air and fuel and the expulsion of exhaust gases. Fuel system supplies the engine with fuel through components like fuel injectors and carburetors. Transmission system. The transmission transfers power from the engine to the wheels by adjusting the gear ratio, ensuring the engine operates efficiently during acceleration, cruising, or hill climbing. Types of transmissions. Manual transmission requires the driver to shift gears manually using a clutch and gear stick. Automatic transmission shifts gears automatically based on speed and load. Continuously variable transmission. CVT provides a seamless range of gear ratios without discrete shifts. Key components: clutch, manual, disconnects the engine from the transmission during gear shifts. Torque converter, automatic, transfers power from the engine to the transmission. Gears, regulate speed and power by adjusting torque. Braking system. The braking system is essential for safety, enabling the vehicle to slow or stop by converting kinetic energy into heat. Modern vehicles feature advanced technologies like anti-lock braking systems, ABS, to prevent wheel lockup during hard braking. Key components of the braking system. Brake pedal, the driver's input to activate the brakes. Brake pads create friction with the rotors to slow the wheels. Brake rotors, or discs, spin with the wheels and the brake pads clamp onto them. Brake calipers house the brake pads and apply pressure. Brake fluid transmits force via hydraulic pressure. ABS sensors monitor wheel speed and prevent skidding. Electrical system. The electrical system powers a vehicle's lighting, electronics, and components and starts the engine. It includes the battery, alternator, starter motor, and various wiring and sensors. Key components of the electrical system. Battery stores energy to start the engine and power systems when off. Alternator charges the battery and power systems while the engine runs. Starter motor initiates the engine's combustion process. Fuses and relays protects circuits from overloads and shorts. Sensors monitor parameters, for example temperature, oxygen, and send data to control modules. Environmental and legal considerations. Vehicle technicians in the UK must adhere to both environmental and legal guidelines that ensure safe, efficient, and eco-friendly practices in the automotive industry. These considerations not only protect the environment but also ensure compliance with UK laws and regulations. Environmental considerations. As vehicle technicians, understanding the environmental impact of daily activities is crucial. Automotive repair and maintenance can contribute to pollution, waste, and energy consumption, so technicians must adopt eco-friendly practices. Key environmental considerations include waste management and disposal. Hazardous waste. Vehicle workshops produce hazardous materials like used oil, brake fluid, antifreeze, and batteries. UK regulations, Environmental Protection Act 1990, require proper handling and disposal through licensed services. Recycling. Technicians should recycle items like oil filters, metal parts, and tyres to reduce waste. The end of life. Vehicles Directive, ELV Directive, mandates that at least 95% of a vehicle's materials are recycled or reused. Chemical handling and storage. Proper storage of chemicals such as paints and solvents is crucial to prevent spills and environmental contamination. Technicians must follow the Control of Substances, Hazardous to Health, COSHH regulations for safe storage, labelling, and disposal. Air pollution control. Vehicle emissions like nitrogen oxides, NOx, and particulate matter, PM, contribute to pollution. Technicians must ensure exhaust systems meet UK MOT emission standards and maintain engines to reduce pollution. Energy efficiency. Using energy-efficient tools and practices, such as switching off equipment when not in use, reduces a workshop's carbon footprint. Legal considerations. Vehicle technicians must operate within a legal framework that ensures safety, consumer protection, and environmental responsibility. Key legal considerations for technicians in the UK include Health and Safety Regulations. Health and Safety at Work Act 1974. Technicians must maintain a safe work environment, wearing personal protective equipment, PPE like gloves, goggles, and safety shoes. Risk assessments are essential to prevent accidents, especially with hazardous materials or machinery. Manual Handling Operations Regulations 1992. Vehicle technicians frequently handle heavy parts. These regulations ensure proper handling techniques, and mechanical aids are used to avoid injury. Consumer Rights and Product Safety. Consumer Rights Act 2015. Technicians must perform services with care and skill. Parts provided in repairs should be of satisfactory quality, and defects should be fixed within the warranty period. General Product Safety Regulations 2005. This ensures vehicle parts, especially safety-critical ones like brakes and tyres, meet high safety standards. MOT testing and compliance. Technicians must follow VOSA standards, be certified to perform MOT tests, and ensure vehicles meet safety and environmental regulations. Regular equipment calibration is required. WEE regulations. Technicians must dispose of electrical components and batteries safely, following the Battery Directive for hazardous waste disposal. Sustainability. Initiatives in the automotive sector. With a growing emphasis on reducing carbon emissions and improving air quality, the UK government has set ambitious targets for the automotive industry, including phasing out petrol and diesel cars by 2030. Technicians must stay current with these changes, focusing on electric and hybrid vehicle maintenance. As electric and hybrid vehicles, EVs, become more popular, technicians need to develop skills to work with high-voltage systems. The UK offers certifications for EV repair, ensuring technicians can handle these vehicles' challenges. Understanding EV-specific legal considerations like high-voltage safety regulations is crucial for safety and compliance. Emissions standards. The UK is continually tightening emissions standards, with the latest being the Euro 6 standard. Vehicle technicians must ensure that vehicles comply with these standards by maintaining emission control systems such as catalytic converters and diesel particulate filters, DPFs. Technological and ethical considerations. Data protection and security. As vehicles become more digital, technicians are responsible for handling sensitive data, such as vehicle telemetry and driver information. Compliance with the General Data Protection Regulation, GDPR, is mandatory when dealing with any personal data collected from vehicle systems. Ethical disposal of vehicles. Under the End-of-Life Vehicle (ELV) Directive, technicians are legally required to ensure that vehicles that have reached the end of their life cycle are disposed of ethically, prioritizing the reuse, recycling, or recovery of materials. Highlights from this module: health and safety in workshops prevent accidents, ensure compliance, boost productivity, and protect tools and equipment. Effective tool use in vehicle workshops ensures safety, precision, efficiency, and prevents costly equipment damage. Selecting the right tools, proper handling, and regular maintenance improve efficiency, safety, and overall quality. Vehicle workshops must manage hazardous waste, recycle, and control air pollution, adhering to UK environmental laws. Legal considerations in vehicle workshops include health and safety regulations, consumer rights, and compliance with MOT standards. Thank you. You have successfully made it to the end of this module.